Time basically we are calling that is the initial set of concrete. Now, initial setting time of concrete depend on several factors such as cement type, water cement ratio or water binder ratio rather. Right now we are not using only a cement. Along with cement we use a lot of other materials. Then temperature at that particular location where you are producing the concrete. You may be producing here in Mumbai or in Delhi or in Himachal Pradesh. That also it affects, the ambient temperatures or conditions are different. Then relative humidity. If you do in Mumbai, maybe 60, 65, go to Bombay, Pune, it might be 30, 35, very dry weather, or Indore, Delhi. So relative humidity, drying, means air drying is very, very fast. And air temperature, temperature of the concrete and air temperature. All these factors are affecting initial setting time of concrete. Generally, a normal concrete, it is about 2 to 3 hours. So where you are not use any retarders, you are use only plasticizer, it is within 2 to 3 hours, concrete sets. That is initial set. And if you have retarder, it can be extended this time as per your requirement. When I am making this assessment as per your requirement, the setting time can be tailor made. Can have 4 hours, we can have 8 hours, we can have 10 hours, we can have 24 hours, we can have even up to 72 hours. So concrete will not set. Depending on your site requirement and the dosage of retarder and superplasticizer, we can add into the concrete and your concrete will remain workable. Before initial set time, concrete is workable and you can place it, vibrate it, finish it till that time, till the setting doesn't take place. So today such chemicals are available and we can design the concrete depending upon your project's requirements. So this is important whenever you are doing very big, large pours, even the normal slabs. And a very big slab where we are not able to complete within a day. And you don't want any construction joint or cold joint. I can extend that concrete setting time till that time my next concrete will come. So concrete is alive. So you can pour next concrete on that and vibrate it. It will merge with the earlier concrete and get a jointless concrete. Generally, civil engineers are confused with setting time of cement and setting time of concrete. Today, we are discussing setting time of concrete, not the cement. Cement, concrete setting time of cement, we conduct in a controlled conditions. The particular relative humidity, particular temperature, and with only cement paste. That is the indication of that particular cement is meeting the IS requirement. And IS has given that minimum 30 minutes, maximum it can go up to 600 minutes, means 10 hours. Within that range, the setting time of concrete is there, cement is there, then can be utilized as accepted as per the standard. So when you are doing cement setting time under control condition, where your water cement ratio is fixed, it is not a exact fix, but there is a near to that because it is depend upon your consistency. But temperature RH is fixed and there is no aggregate in it. So setting time of your cement is different than setting time of concrete. So today we are just discussing about this is setting time of concrete. Why it is important? Because we'll have a jointless concrete. Wherever there is a joint in concrete, definitely that is the weakest point and we may have a lot of other issues. Leakages are there, all these issues are there and the transfer of stresses because if there is a joint, the stresses may not transfer 100%. So initial setting time of concrete workout for the degradation of hardened properties. Normally requirement depend upon the type of construction, where more difficult placement for longer setting time required and hot weather concrete or there's a long haulage. Suppose I had to transport concrete from Mumbai to Pune. I know it takes 6 hours or 4 or 5 hours. So till that time I can make concrete alive. Once reach there, I can use as is normal concrete and it is hardens and achieves the desired properties in the concrete is possible. So much importance is there for the setting time of concrete, but we rarely conduct this test in projects. Wherever very big projects are there, people are doing because there's a large pour and we don't want jointless concrete. It's possible about 10,000, 5,000 cubic meter concrete you have to do continuously without any joint. Can have such concrete where jointless concrete can be possible today. See like this cold joints. This concrete has done and then afterward there is a stoppage. And then second lift has come. So this is the cold joint, which can be avoided. So my concrete setting time, I can decide such a way that whenever my second layer of concrete placing is there, my concrete which is already poured should be alive. Alive in the sense it should be respond to vibration. That is possible today. So how to determine the setting time of concrete? There is a procedures given in IS 1199 part 7. Earlier it was there and still that code is not withdrawn because all the parts have not yet released of 1199. There are 12 parts what we have discussed earlier. So this is part 7 setting time of concrete by penetration resistance. It was given in IS code 8142. You can note down IS 8142. You can refer that code to find out setting time of concrete. Initial setting time of cement is a code is different, and as I said, cement is only on the paste. This is on the concrete. You can find out initial setting time, and also we can find out final setting time of concrete, where the strength is around 7 MPa, zero point 0.7 MPa, which is sufficient to stand by its own weight. Its vertical members can stand. So vertical sides can be removed after final setting of concrete. But ours for the execution team or the project, initial setting time is very, very important. So how to assess that? The setting time elapsed between initial contact with cement and water required the mortar to be sieved from the concrete to reach penetration resistance at around 3.5 MPa. Once the resistance come to this level, we say that concrete has set. Now, once we are saying this concrete has set, then you are not supposed to disturb that concrete. You are not to vibrate the concrete because the hardening process has started. And you will find your concrete is not responding to vibrations, not responding to the vibrations. So this is the stage where concrete is not vibrating. The final setting time, same value is reaches to 27.6 MPa that concrete has set, final set. So you can take or you can start curing, normal water curing, or vertical members can be loosened out and removed. So resistance level. So around 5 to 6 MPa strength will be there. So that is more than sufficient. No, zero point 0.7 MPa, not 0.6 MPa, 7 MPa strength. That is sufficient to de-shatter your normal members, not a large members. So how to do this? You take a concrete, fresh concrete, sieve through 4.75 mm sieve. Now this is the concrete. You sieve through this 4.75 mm sieves and remove all the aggregates. Remove because all your water and cement, everything ingredients and gone into that particular concrete. So while testing, you take concrete which is less than 4.75 mm sieve. Take this mortar, cast the cube, cast normal cubes. Maybe you have to take number of cubes. One cube is not sufficient to take testing because you may feel that concrete has not yet set. So you have to cast number of things and cast slightly below the about 10 to 12 mm below their top surface. A lot of bleed water will there, it will come on the surface. So with the normal compaction method, you cast with the mortar and note down the temperature of concrete, note down the temperature, ambient temperature, and note down the RH value. And whenever you are doing this stage, these values are very, very important because when you are producing from the plant, those conditions may change. Or you keep the same conditions where this concrete planning to place or use. So in that location also, you can take these cubes and keep it there and take the periodic penetration. Now this is the small pocket penetrometer. It's a spring loaded and calibrated equipment. So it has got nozzle one end around 30 mm. So we have to penetrate 25 mm inside the concrete and diameter is around 5 mm. So once you penetrate this, the concrete initially is flowable or maybe having high slump or slurry. The penetration go very easily. You will find there is no pressure resistance from this particular equipment. Now next reading you take around 25 mm from here, which say another half an hour or 1 hour. Initially you take every half an hour or even take after 1 hour, and then we'll find as time goes this is offering some resistance because concrete is start setting. Once you start setting is offer the resistance, you take number of readings till it is reaches more than 3.5 MPa stress at penetration of 20 mm. 25 mm, not 20 mm, 25 mm penetration levels. And this similar because that hand operated equipment is not suitable to find out final setting time of time because stress is very high or your pressure is very high. So we have to get equipment like this with different diameter. Then you plot a graph with time and penetration resistance on the calibrated equipment and plot a graph like this. And you will find that 3.5, and this is the time, maybe 270 and 280 level, it has take a initial set. And final set 27.6, maybe around 390 minutes. Now this time will vary with the your type of cement type, water binder ratio, ambient conditions. This time will vary. It may go to 300, 360 like that. And suppose your temperature is very, very low, say maybe 5 degree, 10 degree temperature, this may go even 24 hours. So in summer, when concrete is setting very fast, I can use some retarder and get setting time as per my requirement. So this is very, very important test for execution time. And whenever we are using such uh, concrete with admixtures, because admixture also contains certain part of retarders, and these retarders are responsible for delaying setting time. So same admixture if you use in winter and then in a summer, definitely setting time of concrete with the same dosage with the same mix will be different. That one has to understand. And accordingly, you select the dosage of your admixture for your required setting time of concrete. So this is what important of setting time. And whenever you are doing at site, you must understand that setting time is very, very important. This can be avoided your construction joints. And as I said earlier, it is possible to get a concrete having more than 24 hours setting time also. Another studies and observation, even our observation says, whenever there is a delay in setting, suppose you are using X dosage of admixture and the system has failed and he has given double the dose, you will find concrete has delayed the setting. Lot of sites you will understand concrete has not set for 48 hours even. Now everybody is panicky, what to do, how to do, what to do. But one as a civil engineer, you must remember if the concrete setting is delayed without adding any water, I'm repeating this statement, without adding any water, only due to the admixture dosage has gone higher, there is a possibility concrete will not set maybe 48 hours, 72 hours also. But if you keep concrete as it is, don't disturb the concrete till it sets. Once it sets, it develop the strength on the normal pattern, and we'll surprised to note that the 28-day strength of that particular concrete will be higher than normal set concrete. This is observed in the field also, and there is a lot of research papers also there. Anybody is interested, they can. Wherever people are using two component system, they're using plasticizer and they separately using retarders. And anything goes wrong with the, because retarder dose is very, very low compared to the normal super plasticizer dose. So they are only super plasticizer no retarder, and there is separate component is your retarders. So anything goes wrong with the retarders, suppose dosage is gone double, you'll find concrete has not set even at 48 hours. One of the important project where they did the concrete about 250 cubic meter in one particular foundation. Out of that, 2 cubic meter as concrete has not set for 21 days. I said after 28 days they can remove easily by hand. So such thing is also possible. So if the concrete is within suppose 24 hours, 48 hours, don't be panicky. Don't take sudden decision that you should demolish the structure. You should wait till it sets and let him set at a standard procedure. You will find the strength of the concrete is higher than normal set concrete. So that one has to understand as a civil engineer. This is generally happen on when you are doing vertical members and concrete delay without checking the cubes and concrete has set. They start de-shattering, you'll find everything gets collapsed because concrete has not set. So such things are possible at site, such accidents are possible at site. So as a civil engineer, you must take proper call on this. Use your engineering knowledge and take a call. Don't be panicky on only on the setting time of concrete. It is only a delay in hydration process. Once that hydration process has started, the concrete will set at normal setting time. At 28 days strength is higher. We have taken a lot of cores like in the concrete and found that strength is more than the normal set concrete. So that is one of the our studies shows. So don't be panic on that. Another property, I think we have discussed this, but I'll just giving again because this is always a issue today. Today we are facing a lot of issue. Concrete is become of having bleeding. That is clear water coming on the surface. And that particular top surface having very high water binder ratio, it become weak and that is a give also dusty nature. So this is method is given in 9103 also, which is this is the code for admixtures. Also at a, it is also included in your 1199 latest code. So whenever there is a bleeding in the concrete, you have to avoid that finer cement. Use finer cement. Reduce water content. Unit water content can be reduced or increase the minus 300 micron in the mix. This particular fraction is coming from your admixture, not admixture, crushed sand or natural sand. If your sand is lacking in this particular fraction, you will find this concrete will bleed. So there is a test. You do the normal test and find out what percentage bleeding is there when you are doing mix design, and appropriately you correct in the unit water content. Or you can use air entering admixture, which can take care of that extra water covered by your air. Slight amount of bleeding is desirable, not very high bleeding. Sometimes we'll find about 5 to 10 mm thickness of water layer is there on the concrete once you finish the concrete. That is not a good concrete mix design. So one has to remember that and find out. See this. This is the bleeding water. See here. This once you vibrate, you will find it is coming on the surface and it is a very clean water at the top. and whole paste about say 20-25 mm paste is with very high water binder ratio, which will give very low strength. And with the time also it is erode because abrasion will be taken place, and with a low strength it will definitely have low wearing resistance. You can see here bleeding. You can see this water layer here, that is called a bleeding. And once the bleeding is there, there is also settlement. And normally have the issue of settlement of your mix. Some bleeding, as I said, is required to help control the plastic shrinkage cracking. So we have to design such a way very light bleeding will be there, but there should not be a very high amount of bleeding. That during the mix design process, we can find out how much percentage is there, and that much water can be reduced from your unit water content. And then this plastic settlement, you can see here, because this concrete has settled, and there the reinforcement is there. The reinforcement is not allowed to go the concrete settled. That's why it is found a crack. So you can see the grid of your reinforcement pattern. Another that whenever there is a thickness, very high thickness and high flow, the person who is vibrating, he feels that so much flow is there, not required to vibrate. But with the time, it settles down. That's why we always advise that concrete has to be in layers. You do one layer, vibrate it, then you put second layer. But if you put everything in one go, definitely with the time, concrete will settle down and will get plus the settlement cracks because of the reinforcement is resisting that particular paste or concrete.